Hello students, welcome to Eganeet. Today we are going to take the 11th problem of exercise 10.2 of chapter 10, that is circles. Okay, so let's read the problem first. We have to prove that the parallelogram circumscribing a circle is a rhombus. Okay, so we have given that a circle with center O. Quadrilateral ABCD is a parallelogram that is circumscribing a circle, and we have to prove that this parallelogram, that is quadrilateral ABCD, which is a parallelogram, हम लोगों को prove करना है, that is a rhombus. Okay, so here we are using the property of the sides of the rhombus as well as the parallelogram, and we are using the property of a circle and tangent, that is the tangents drawn from an external point to the same circle, they are equal. Okay, so we are using these properties, so let's do it now. Okay, so here I can say AS equal to AP equal to, that is x. Tangents drawn from an external point to the same circle, they are equal. Then BP equal to BQ equal to y. Again the tangents drawn from an external point to the same circle are equal. CQ equal to CR equal to Z. So this is Z, and DS equal to DR equal to W. So this will be W. So here we are using the property of tangents drawn from an external point to the same circle are equal. Okay. Now a parallelogram and a rhombus. In parallelogram we know that the opposite sides of the parallelogram are equal, and in rhombus we know that all sides of the rhombus they are equal. But if I want to prove a parallelogram, a rhombus, then if I prove that the adjacent sides of the parallelogram are equal, then we can say that a parallelogram is a rhombus. Okay, so let's do it now. ABCD is parallelogram, and therefore we can say AB equal to CD. That is opposite sides of the parallelogram are equal. Okay, now what is AB? So AB will be x plus y. What is CD? CD is z plus w. Okay, now on adding these two, I am getting AB plus CD equal to x plus y plus z plus w. Okay, but we know that AB equal to CD, opposite sides of the parallelogram are equal, so I can replace this CD by AB. So what I will get, AB plus AB is nothing but x plus y plus z plus w, and AB plus AB will be 2AB. So 2AB will be x plus y plus z plus w. I am calling this as equation 1. Okay. Similarly, I can say BC equal to AD, that is opposite sides of the parallelogram are equal. Now what will be BC? So BC equal to y plus z, and what is AD? AD is nothing but x plus w. So on adding this, AD plus BC will be x plus y plus z plus w. Okay, again we know that AD equal to BC, so I can replace AD by BC. So this will be BC plus BC equal to x plus y plus z plus w. Okay, so indirectly I am having 2BC equal to x plus y plus z plus w. I am calling this as equation 2. Now if you look at the equation 1 and equation 2, the RHS, they are same, that is x plus y plus z plus w. Okay, so I can say twice of AB equal to twice of BC. Okay, on cancelling 2 from both sides, I am getting AB equal to BC. Okay, so what do you mean by AB equal to BC? That is the adjacent sides of the quadrilateral ABCD, they are equal, but we have given that quadrilateral ABCD is a parallelogram, and in that parallelogram we have proved that AB equal to BC, that is the adjacent sides of that parallelogram, they are equal, and therefore we can say that quadrilateral ABCD is a rhombus. Okay, so that's the proof of the given problem. To get the solutions of other problems of this exercise, do visit our website www.eganeet.com or download our app Eganeet from Google Play Store, and keep enjoying maths. Thank you.